In this review of conic sections, I do want to remind everybody that technically there are 4 different kinds of conic sections. There's the circle, the ellipse, the parabola, and the hyperbola. However, because a circle is basically an ellipse with a certain restriction on it, we're only going to talk about 3 different kinds of conic sections today. It's going to be the ellipse, the hyperbola, and the parabola. What we're going to do is just a really quick way of identifying what kind of conic section you have based off of an equation. Now again, these are referring to traces, so there are only going to be 2 variables present in them. For an ellipse, you'll be looking specifically for a sum of 2 squares being equal to some other quantity. Whereas for the hyperbola, you'd be looking for a difference of 2 squares. I don't know why I started writing x in there. I don't know why I wrote 0 there. I'm all over the place right now. If you have a square minus a square is equal to some other quantity, or I guess technically a little bit of algebra could let you know that if you had a square is equal to another square with other things added or subtracted around, these are essentially equivalent to each other. So, big important thing is if both of the variables are squared, you're dealing with either an ellipse or a hyperbola, and the plus or minus is going to determine which one it is. As far as the parabola is concerned, one of your variables will not be squared, and one of your variables will be squared. Now, I'm writing an and, or an ampersand, in between them because it doesn't matter if they're added, subtracted, doesn't matter if they're on the same side of the equation or opposite sides of the equation. That determines the orientation of the parabola. It does not change the fact that it is a parabola. So, for example, if you saw something along the lines of x minus 2 squared plus 4 times y plus 1 squared is equal to 1. There's a square, a plus, that's an ellipse. In the second case, if you saw, for example, y squared is equal to z squared plus 1, we'd be talking about this sort of thing here, where they're both squared and they're on opposite sides of the equation. You'll notice that this is also algebraically equivalent to y squared minus z squared is equal to 1. Both of the variables are squared, there's a subtraction sign in between them, that's definitely a hyperbola. And for the last one, if you saw, for example, z squared is equal to 4x. Again, it does not matter that they're on different sides of the equation. What matters is that one of your variables is not squared and the other one is squared. This one is a parabola, hyperbola, ellipse. Done, done, and done.